So we'll start in 1 or 2 minutes. Yeah, shall we start?
Yes, I guess so. Yeah.
Okay, so hello everyone. So just it's a open session. So like you can ask if you have any doubt or if you have any query. So I just want to know, like, I hope everyone has performed this experiment. Like to all summer school participants and the refresher course participants. So did you guys face any issue or do you have any queries while performing this experiment? So you can unmute yourself and you can ask.
Or if you have difficulty unmuting yourself, raise hand.
Yeah, please raise your hands or you can like text us in the chat box. The first question is like, did you like perform this experiment by yourself? And so what were the like instruments you used for the experiments? So may I know this? Especially refresher people who are attending there, because they may have to submit a report at the end. So,
Okay. Can people indicate if they have already done the experiment by?
just raise your hand who has done this experiment. So we'll also get to know whether they're done or not. So can we know how many of you have performed this experiment?
Yeah, this busy hour is expected to just
Yeah.
serve, additional help from our side that we are present, and you can bring up any difficulty that you might have faced, or you could use this hour to actually perform the experiment. Okay, and as you go along, any difficulties you face, you can bring them up.
Megha has, she said she has done this experiment.
Okay.
Yeah. Nisha, go ahead.
When I tried this experiment, so I just got 2 dips. After that, I stopped getting any changes in the signal. The signal remained constant throughout.
Okay, so what was the signal level?
It was around minus 35 on average.
And it was not going beyond that?
No, in between twice it went to around minus 20, but then it got stuck at around minus 40 and it just stayed there.
Okay. So what was your transmitter? Cell phone?
Transmitter was my phone and receiver was my laptop.
Okay, so what is the distance between the transmitter and receiver and
Yes,
reflector?
I actually I didn't measure the distances. I just wanted to get a
Okay.
rough idea before I went into the data taking.
Okay.
Uh,
And the
to remind myself, this is the back reflector experiment.
back reflector. Yeah, this is back reflector experiment.
Okay.
And what was the
Right.
distance between the reflector antenna and your transmitting device? Did you measure that?
Hello, sir?
Yeah. So did you measure the
No,
distance
sir.
between the
Actually,
transmitter?
no. I just kept my apparatus and I wanted to get a feel for the experiment. At random, I just kept it and let it run.
Mhm. No, but without
So,
changing distance between the
no,
reflector and transmitter, how will you get to know that it's changing?
no, at a particular distance, we must get. So we have to take the data for several distances, right?
Yeah,
Yes.
of course.
Find out the optimum one. Also identify the one which gives you the maximum signal.
Okay, so I'll try it again. Thank you.
Yeah. Any other question, doubt, query?
Or information from your side.
Yeah, something which you can expect.
We are presuming that all of you have some way of measuring the power level, and those issues have already been sorted out. That you have a setup where there is a radiator, there is a back reflector, and there is a measurement device. If anybody does not have that yet, please bring that up. We will like to help you to sort out any difficulty you might have faced in getting that set up. Okay, looks like most of you, all of you here, certainly have the setup. So if I may share a screen, can you see my screen?
Yeah, there we can see.
Okay.
So whiteboard, right?
Yeah, yeah. So we expect this very simple arrangement. Okay, a back reflector, right, at some distance, your phone or whatever radiator, right, and your measurement device. So what we are expecting is that this distance to be changed variation of this distance, and as a function of this, we would like to know how the power changes at this place.
So we can change the distance Ritesh?
Pardon?
Yeah, so I thought you were saying something.
No, yeah.
Yeah,
So
so
this is the distance to be
can
varied
change.
between the back reflector and, or to be indicate that more properly here. And then you would say some variation, right, of the power. I'm drawing a very arbitrary. So what you would have is a reflector distance and power. So based on the wavelength that you're using, whether it's 2.4 gigahertz or 5 gigahertz, uh, which will have corresponding wavelength of about what 12 centimeters and 5 centimeters 6 centimeters respectively. You would find at some distance you will get maximum power, right? And that distance will have some relation with the wavelength of the signal radiated. So we purposely kept this as a busy hour where even if you have had no time to do this experiment, you could use this 1 hour in a focused way to perform the experiment while we will be available online to address any issue that you might come up with. So we will be here for an hour and feel free to even go offline, do your experiment, come back when you have something to discuss or ask. Is that fair? I've stopped sharing.
Please go ahead. So otherwise we won't be able to understand sort of a better other issue because our next experiment is based on this. So if you are able to understand it clearly and thoroughly, so then it will be very easy to do the next experiment, which we are going to do like, on Friday. Hope like everybody is like familiar with the experiment and successfully you could take the observations using your devices. So, any difficulty installing the softwares on any other platform?
Yeah, is there anyone here who has had any difficulty in installing or identifying the application app or installation of any software to be able to conduct this experiment? This might be the best time. We have Ashish and Jameer who are experts in these aspects as well, who would be able to help you. But if you have all that setup ready, then it's perfectly all right for you to disconnect from the session so that your devices, mobile devices that you want to use for the experiment are free for you to use for the experiment and go ahead, perform the experiment, and then come back, rejoin, and tell us the status of your effort.
Desh, we have a question online which was asked. So,
Yes.
yeah. What will be the adequate size of the reflector if we are using a smartphone as a transmitter?
Yeah, let me see the.
Not in the chat box. It was.
Let's try to see the question. Oh, I see it's in the chat box. I see. Oh, I'm not able to see that.
No, it's not in the chat box.
Oh, it's not in the chat.
Yeah.
In the yeah, right. It's in the Google Sheet, right?
Yes.
Okay. Okay. Size of the reflector. Does the size of reflector matter? Yes. The size of the reflector will matter up to a certain point. It shouldn't be too small. It should be at least a few wavelengths across. And certainly in terms of ray optics, you can imagine the rays that are likely to have significant reflection in your direction. There you need to provide the reflector. But as you know that the geometric ray picture is not what is actually operative in this. The entire physical optics is at play. So you will find that the wavefront launched by your radiator in the direction behind is going to be treated by the reflector, and the reflector size is small, then its diffraction pattern will begin to also matter. So since you do not want that to be the prominent modulation, you can keep the reflector a few wavelength across in size. So for the wavelengths we are operating, something like even 1 foot across in either direction should do reasonably well. Does it answer the question?
Yes, thanks. So
there is one more question there. You can see, or is it a comment?
Yeah,
okay.
So there's one more question.
As we have
that the receiver is receiving constructive interference at the other end, does it also mean that overall strength coming the transmitter has also?
Yeah, so the overall strength coming from the transmitter does not increase. The transmitter doesn't know what you're doing in terms of any reflections or any other directional emphasis you might be giving. What happens is the increase in the direction that you see, which is perpendicular to the direction of the perpendicular to the reflector, comes at the expense of reduced power in the other directions. So the total integral of the power over the entire radiation zone 4 pi steradian remains constant, and that is corresponding to the power being output by the transmitter. It is just that power that was going in other directions is now channeled in more preferred directions, which is the forward direction in this particular case. Does it answer that question? So the transmitter spends the same amount of power. You increase the directivity of the of the transmission of the power. Of course, it will have to come at the expense of reduced power in other directions. Does it answer your question, Akshat? I don't know whether
I don't know where
person is there or not.
but this is not here.
But similar question might have been in minds of other people as well.
Yeah, so that's why I'm asking. Yeah, sure. Go ahead.
Hello, am I
Yeah.
actually, I wanted to know that how is this experiment, like the method used in this experiment, how is it applied in astronomical studies? Like, what are its applications?
Yeah. So can I share a screen again? Just for okay. All right. So suppose you have a simple. So of course in astronomy, I'll first mention the. Okay, maybe we even mention the context of. Suppose you want to radiate something or receive something from certain direction. So you have a simple element here. I'm showing it as a dipole. Doesn't mean that it's has to be always dipole, but an element that is an antenna. And then if we put a reflector here, the idea is that the in the radiation case, which is the experiment you're doing, right? Power is radiated in all directions. You do not suppose you're not interested in sending the power in that direction, then you could use that profitably to reflect and add coherently to the signal going in the forward direction, if that is where you want the enhancement. And it will turn out that this distance then will have to be lambda by 4. Okay. The reason for that is you would like to add this signal to the forward going wave in phase. By in phase, you mean the phase difference should be 0 as far as possible, modulo 2 pi. So you get for lambda by 4 distance, you will get a phase shift of pi by 2, right? One way, pi by 2 the other way. And so that will make it pi. And the reflection itself, change of direction, amounts to a phase shift of pi. And that together makes it a difference of 2 pi. That's why the distance such as lambda by 4 works best for enhancing signal in the forward direction, the direction defined as that perpendicular to the reflector. Now, where do you use it? You will use it for when you make an array of antennas, right? You would like to put a reflector, what is called a ground reflector, at that distance, and that will enhance your reception. So what works in transmission works in reception. That's the reciprocity theorem in this context. And so radiation coming from a distant source will also be received by your antenna. Not all of it will be picked up. Part of it will go through and you make it bounce back and make sure that it adds in phase. So in process, what happens is the response, if you plot the directivity, it will be enhanced in the forward direction, which is vertical, and reduced in the direction that you do not want any response. So it serves as a blockage for the radiation coming from the ground, particularly when you're looking at very weak signals and the ground is hot compared to, because the ground is also radiating as a black body, if you like. And that radiation, if you do not want it to interfere, you cater to only signals coming from the upper direction. So this is one application. If you want to look at how it's used in a dish-like antenna like the GMRT, right? You will have a well-defined focus, right? And there, if you want to put some sensor element, much like the way your receiving antenna is, then you can enhance. You would like to look at radiation that is coming from somewhere, right? In this particular case, of course, let me not draw that. Radiation coming along the axis, right, is to be gathered at the focus. And when you do that, you do not want there is sky radiation coming directly also at the place where your sensor is. And if it had response, it would see what is being reflected from the reflector and as well as what is coming from directly from the sky. So you want enhanced look for this region, then you would gain by putting a reflector here. This reflector need not be just the plain reflector as you're using this experiment. It could be a shaped reflector also. And the simplest shape of making it even better than a plain reflector is a corner reflector. Something that you can also try as a part of this experiment if you were to experiment to see what the effect of a corner reflector would be instead of a plain reflector. So these are the applications. The idea is to try to modify or improve the performance of a receiving element antenna in directions of interest and reduce its performance or ability to receive radiation in directions that are undesired.
Thank you, sir.
Of course, these have to be metal conducting reflectors, okay, conducting materials. And it's not just true of a nice plain reflector and so on. Any metal put by the side of or within certain influencing distance of your radiator or receiving element will have its own imprint on the way the field is going to appear to the receiver. And the combined effect of it is what will decide its ability to receive or radiate. Even to the extent where if there are multiple antennas kept next to each other, they also begin to influence each other in a manner which is sometimes undesired. Sometimes you can use it profitably, and it is known infamously or famously as mutual coupling. Any other question, query, comments? So my naive guess is most of you who have stayed back have already finished the experiment and have had no difficulty in doing so. In which case, you might want to share what you found, or any comments that you might have relating to your measurements that others also might be interested.
If you want, you can share your result.
Yeah, feel free to share your screen to show any pictures that you would like to share with your peers.
Anybody is willing to share your result? Yeah, Vinisha, go ahead.
Sir, actually, I have a question.
Yeah.
Also, for the same distance, my signal strength is fluctuating over a wide range. So, which value am I to record?
So, what is the range? What is the minimum?
So, around from 38 to 48.
Okay.
It's not settling down.
So,
are you using the phone for anything else parallelly that might
No, I
be
am
using
turning
the
off
power
my
for?
data.
I see. Okay,
So-
are things otherwise steady in terms of any movements and so on?
Sir, actually, my mobile, when I'm switching off the mobile data, is just getting disconnected from the laptop. I can't seem to get around the problem.
okay.
Okay.
So this is like indoor, or you're doing this
This is I'm indoors.
inside the room, right?
Yeah.
Yeah. So you may expect little fluctuation because of
Are you
reflection.
which side of the line joining the two devices you are on? Are you in the middle? Or?
No, I'm outside the range.
Okay.
I'm 20 feet.
Okay. So leave it steady and see of which, of course, you can take the attitude that you will take the maximum each time you get this reading, right?
Yes, sir.
Because the maximum cannot be produced by chance. The minimum or low power can be produced by some other difficulties, dropouts, and so on.
And so my laptop just gets disconnected when I switch off the mobile data. So how do I get around that?
Laptop switches. Oh, you mean the signal goes off
Yeah.
when you switch off your mobile data, which is on the transmitter, correct?
Yes, sir.
Yeah. So I think you can just hope that. Is there some low data mode or some such thing?
No, when I switch on this flight mode, the same thing happens.
Okay, yeah, some mobiles have that difficulty. which we had been made aware of. So I think there one simply hopes that you know that the activity of radiation activity heavily tied up with the data rate is not too much. So as long as it's not downloading something madly and so on, it's fine.
Okay.
You can keep most of the activity as much as you can off on the device.
So why would that matter? What kind of error would that cause?
Yeah, because I think that it boosts the power many times. Okay, when
Okay.
it's trying to connect and not getting, even when you're trying to make a call,
Yeah.
the radiated power is not always constant. When it finds the tower close by, it uses sort of the nominal power. But when the signal level is low, it might boost the power radiated to make up for the low signal level.
Okay, sir. Thank you.
Basically, it's trying to do good for your battery, right, in the process. These are nice optimizations that you would otherwise want. Except for this experiment, we want a steady source of radiation. So it would be okay to say that you take the maximum within each reading, whatever span you take. But then you also have to wait sufficiently long so that you get hold of such a reading in the middle of. The other nice thing is to say take average, but then the average really has to be taken not in the scale of dBs, ideally in the linear scale. It certainly makes it harder because the intrinsic assumption there is that radiator is behaving the same way during each one of the measurements. Okay, even if it's fluctuating, it's having similar statistical fluctuation during span of each reading, so to say. Which is, there is no guarantee for that to be true, which we can only hope. The other thing is a router as well, or any other phone where it can be put in flight mode and the old type phone. The newer ones probably have all this implicit connection with the flight mode and the radiator. Okay, any other comments? So I would encourage any one of you who has done this experiment and has something tangible recorded that you can share. We would encourage you to share so that it will also help others to get a feel for things the way they are supposed to appear. And they might bring up issues which might underline the differences between what they have seen and what they will hear from you. Any volunteers? Many of the people we see right now as participants might be actually conducting the experiment. They might have on some other device logged in onto the Zoom. So lack of response from them is understandable.
There are no questions or doubts. Maybe we can close this session. Suresh.
Yeah, maybe we can ask them if they want us to continue. Because some of them might be actually not listening to what we are saying. They might be busy doing their experiment. In which case, I think it's to probably post this question on the chat box, which might attract their attention. In case they are.
Any doubts from the fresher course participant, especially?
Okay, I posted something on the chat box in case.
Okay.
Also, telling them that we will close in 5 minutes if there are no further questions. Yeah, it would have been nicer to have seen any results of their uh, experiments from people who have already done it.
Actually,
But maybe they are in the sort of could have been in the half done stage, in which case. There is a question: is there any video demonstrating the power level measurement? Okay, I'm having the results which vary significantly when repeating the experiment. Okay. Yeah. So the suggestion is that when you take a particular reading at a given distance, or without changing the setup, you will find there might be uh, fluctuation in the power. And if you were to make a plot of that, you will see the sort of level of variation apparent, and from which you can even assess the mean value uh, that it gives in the presence of this fluctuation. That might be more repeatable uh, when you repeat the experiment, or at least the pattern, relative pattern of how the different readings in a given setup relate to each other uh, as you vary one of the parameters like distance of the reflector here. Ashish might know, is there a video demonstrating the power level setting testing anywhere in the web readily available? Or
For this experiment, I don't think there is
not
a
this
video.
experiment? No. I think his question is very general. The power level testing, right?
Okay, using this kind of.
Using these kind of devices, okay? Is
Okay,
there a demonstration of the kind of fluctuation that occurs, and the level of how the level is assessed in practice? Or you
okay.
might have your own comments to add.
Well, I can check, or actually, we can make some videos and put them on IUCAA website.
Okay, but right now, what would you recommend the person to see or look at, so that they have a feel for what is the level of variation, whether that variation is supposed to be acceptable, is it unusual, or is it expected? On that,
Uh,
you can make a comment already yourself, I suppose, from your experience.
yeah. So from what I saw was that the power level the minimum that it can go to is minus 90 dBm, and beyond that, it's basically, yeah, the device is no more sensitive. Uh, but within suppose you're doing in closed rooms, then the power levels should be around 30 to 40, minus 30 to minus 40 dBm. Outdoors, this number may change a bit, but below,
It might change because you might use bigger distances. Otherwise,
yeah,
it should not change. If you are keeping within reasonable distance.
yeah. So inside the room, actually, if your measurements don't match the expected results, then probably there are some reflections, and they might give some higher or lower dips than expected. So that is also possible. Uh, Another thing was that mobile to mobile. I mean, if the mobile is transmitter and another mobile is a receiver, using the mobile software, that gave sort of a clearer distinction in my experience, but that may be some isolated incidents. But I also feel that is because uh, laptops they might have some automatic gain controls uh, to compensate for any dips in the power.
Okay. So that will spoil, of course, your observation because the reading has already been modified by uh,
Yes.
the the change in the way the laptop receives. Okay,
Yeah.
gain and so on.
So this I'm judging from the comments that we get in the from the participants. Uh, I personally did not see this variation. Uh, or if there is such a variation, it is. I mean, it might have been not noticeable. Uh, yeah. So, but it also
You can
depends
look at
on.
the chat. There is additional comment from the same individual.
Can't see those. Which we can't see any message here.
So clearly, if the power is like minus 80 or minus 70 or lower than that, then that is not a reasonable measurement. So something may be wrong in the setup. Either you are not connected to the right device or uh, not the right band or something.
Yeah, for reasonable distances within few meters, one expects the power levels to be in the range of minus 30 to minus 40. Is what I
Yeah,
assume.
yeah.
Is that so? My advice in general is to take since I just said that we should take average of and if the statistical variation is similar, uh, we want to take average power in the event of fluctuations. It will be easier to relate to the maximum power received than to the mean taken in the dB scale, because even when it goes to zero, which might change the average only by a factor of 2, in the dB scale it might change by a huge amount, unduly. So simplest suggestion is that stick to the maximum you find in each one of the reading span and then go to the next reading. It might more closely relate to the true measurement. There is one direct message which you may not have seen. Let me read that. What should be the average distance between the transmitter and receiver? Uh, I think it can be as convenient as you can have within the setup of the room, which avoids reflections. So you don't want to be too close to the transmitter, nor too far from the. If you're too close, you are seeing effects where the physical optics resultant pattern has not yet fully developed for you to see the effect in clarity. If you're too far, you're just reducing the power level that you would receive by 1 by r square, and the readings might be low, and they might get, if you go too far, they might get closer to the detection limit of the receiver, which you can avoid. Okay, then there is, oh, by the way, okay, so these are all direct messages. That's why you're not seeing any one of them.
Yeah.
Okay. So, okay, let me. Okay, so Bipin Das had said, is there any video? Okay, so that's what I read, fortunately. And then he had said that I'm having results which vary significantly when repeating the experiment. Then the more technical mention was there. And he said, I think we are using the RS2 column, RS Roman 2 or RSII column of software we are using to measure the power, question mark. You might have.
Yes. So RSSI is basically received a signal strength indicator. So that is the column.
Correct.
So I'm assuming you're using Windows or some such
Right.
operating system. Yeah. Yeah. So there RSSI is the signal strength. Yeah. So this time there are no software installation related queries. Usually
Till
we
now,
get.
we haven't got any queries related to software installation. That's what I was asking them. So if they faced any problems, you can share.
So let me read any other message that has come only as a private message. Let's see. Yeah, so he has said that yes, he's using Windows. Then he had added something that I did not read earlier. I'm only having minus 28 dBm in RSSI scale initially. Don't know what that means in terms of the starting reading, maybe before any changes are done.
That seems reasonable. Yeah, but as you change the distance, the reading should change.
Yes. Yeah, I hope. I request all of you to. Okay, maybe they have very specific questions. That's why they are directly messaging it. But maybe you can directly message to at least 3 of us, which is Ashish, myself, and Jameer. We might, 3 of us might be able to see that comment together. Okay, then there is a comment from Vinisha. who had said about the, what should be the average distance between the transmitter and receiver, says also, do all my devices have to be at the same height? Yes, it's always nicer. Um, Certainly, whatever is the line joining the transmitter and receiver, we want to make sure that the reflector is perpendicular to that. Reflector surface is perpendicular to the line joining your transmitter and receiver. As long as you make sure of that, first part is taken care of. Okay, so that you're measuring along the correct axis. Then if you could arrange them on the same height, it's always nice. There is certain symmetry in the setup. But if you have some serious difficulty in doing that, I would rather suggest that your receiver is at a higher height than the transmitter being at a higher height, so that you will avoid any complications that might come from the reflection from the ground. But the same thing holds good for the roof. So what we want is a less interfered connection between the receiver and transmitter. So whatever you think would help in that regard, in terms of avoiding obvious reflections interfering with your direct path signal, is always going to help. Does it answer your question about the heights?
Yes, sir.
Okay, thanks.
Yeah, also there should not be any walls. Don't keep the setup too close to any walls. So last time someone did that, so I remembered. That might create some extra reflections.
And you might land up doing the next experiment earlier.
Yes.
Inadvertently.
Your setup need to be slightly at a higher height as compared to the ground. So it needs to be at some height. It should not be on the ground. So please try to avoid keeping your transmitter and receiver on the ground. So, and also avoid the walls. And so these are some precautions you need to take care while performing this experiment.
Yeah, essentially think of it as somebody saying something to you from some distance, and you do not want that sound to be bounced off and hear the echoes as well interfering with your direct reception. All considerations in the normal case as we take needs to be taken care of here. Of course, in practical situations, such reflections cannot be avoided completely, but the obvious ones can be avoided. One also hopes for the reflected path to be longer than the direct path, and so there will be reduction due to the variation of or reduction of power with distance, as well as the fact that the reflector may not be reflecting very well. And so both these things put together might reduce the influence of it, but not as much as you might want to hope.
So actually, for the final analysis, it would be better to have all estimates of all the distances. Like if there are walls around, what is the distance of the walls, what is the height of the setup, and so on. So if there are any deviations from the expected result, then you can try and see if there was any reflection, significant reflection.
Yeah, and these values may not be measured very accurately as far as the potential reflectors around are concerned. Have a reasonable feel for them and note it down as a part of in what environment was done. which will always be handy to go back to in case you would like to explain some mysterious deviation in your readings. All right. Looks like, are there any, before we close, are there any pending questions that you would like to bring up? You can simply unmute yourself and ask. Might be quicker. Okay. So all the best with your experiment, and in case there are any difficulties, feel free to post them on this sheet that you had done earlier. We can take them up in the next session.
So on Friday we are discussing the sea surface one, right?
Yes.
Yeah. Okay.
Okay then. See you all on Friday at the same time.
Okay.
Okay. Shall we close this session?
Yes, I think so. Okay, bye for now.